Hello guys, welcome to my YouTube channel Learn with me Dr. Ram. Happy learning. Yeah, today's topic of concern was eutectic solution or eutectic mixture, where the topic where we will get often confused with what is liquidus, what is solidus, and what is eutectic point or eutectic temperature, why the eutectic metal is being used. We will see about all these things in a very easy way. Okay, yeah. First we'll get to know what is liquidus and what is solidus. Okay, the liquidus and solidus are the two words we are going to learn in an easy way. Liquidus, that is when the liquid is start transforming into the solid state. When the liquid is transforming into the solid state, the liquid starts becoming the solid. The point where the liquid starts becoming solid is termed as liquidus. And the point where the liquid starts forming and it completely transformed into the solid. When the liquid is completely transformed to solid, that point is termed as solidus. Okay friends? And in the similar way, when the solid is transforming into the liquid, the point where the solid starts forming into the liquid, right, that is termed as solidus. And the solid where completely transformed into the or completely changed into the liquid is known as liquidus. So for liquid, first point is liquidus, and the last which was completely changed into solid is solidus. And for solid, the first point which was changed to the liquid is termed as solidus, and the end point where solid is completely changed to the liquid is termed as liquidus. Okay, these two are the words that were very important in this eutectic solution. So what is eutectic solution? First of all, what is eutectic solution was when there are two metals combined, where solid A or solid B or metal A and metal B. Okay, when I combine the metal A and metal B to each other in the initial or during the liquid state, both metal A and metal B will be in homogeneous mixture. Like homogeneous mixture, they will be in a similar way, and we can't differentiate that there is metal A and there is metal B into that liquid. But when those mixture of metal A and metal B change to the solid state by the temperature differences, then they are in a combined state. That means still they are in a monoblock. That means if they are in a monoblock state, but we can differentiate that this part is metal A and this part is metal B. During liquid, we can't differentiate that this part is metal A or this part is metal B. Like for example, we take the example of silver and copper. Okay, silver having a melting temperature of 961 degrees centigrade, and copper having a melting temperature of 780 degrees centigrade. Okay, so when they mix it together in a melting state or during the liquid state, we can't differentiate that this part of metal is copper and this part of metal is liquid. But if we gradually cool that or decrease the liquid and transform into a solid state, then we can differentiate that this part of is having of solid, this part is having of liquid. Okay, this part of differentiating of metal in a monoblock phase is known as, this is the main characteristic feature of eutectic solution or eutectic mixture. Okay, and there is this line in this graph. If you want to understand that, this line is is known as liquidus state, where the temperature gradients are going to change. The metal A and metal B are going to come from the liquid state, start forming into the solid state. This is in this metal, at some temperature it is going to solid state, and it this same going to solid state. And this phase, this like what you call U or whatever it is, this phase is known as solidus phase, where the metal is transforming from the solid, this is solid state, into the liquid, solid to the liquid. We have discussed here, right? Liquid to solid, solid to liquid. The same way they are representing on a graph sheet. Okay. Now, if you see what is, there is something called as E point. Okay, this is the main thing we're going to understand today. So in this graph there is a composition here and the temperature here. That is, on x-axis there is composition of the material, and on y-axis there is a temperature gradient. Okay. Now what is something called as E point or E? E means the lowest melting point of an eutectic alloy. That means for the A we have assumed that A is silver and B is copper. Okay, so A is copper and A is copper and B is silver. They have a temperature of 780 and 961. So it was on a higher range, right? Okay. So first of all, E, that is the lowest melting point of an eutectic alloy. So on a combined state it is a eutectic alloy. So lowest melting point for this alloy is E. That means E is a point where A is getting into the liquid, A into solid, and B is getting into the solid. So this point, there is a temperature gradient is lowest, that is 40% of saturation, that is at the temperature of 30 to 40% of the copper. Temperature of, if I am getting 780 degrees centigrade, for me to solder any metal or solder these two metals of solder A and solder B metal, I need a melting temperature or melting solder point which should be lower than these two. Then it will be easier for me to solder, right? So I don't need to melt I don't need a temperature of 780 degrees for A to melt, and I don't need a temperature of 961 for melt B. So E is a point where I will get a 40%, that is from A I can get 40% of the temperature I can get, and from B I can use 60%, that is I can use that in a 40-60 ratio. So the point where for some point of metal where from at the temperature of 40-60 ratio at some point of temperature, let's assume that this was 780, right? This is 780 and this is 961. So this is the point where I can get for about around of 500 degrees. So at around of 500 degrees, a eutectic solder, I can solder A, that is metal A and metal B. I can solder by using at 500 degrees metal. 500 degree at 500 degree centigrade solution, at 500 degree temperature, I can use that E, that is eutectic metal, to solder these two at lower temperature of 500 degree centigrade in a easier way, that I don't need to give 780 degrees of temperature for A and B, because this was a eutectic solution where there are two different metals, or so for the two different every time they not be of silver and copper, right? So two different metals having a common temperature where I can use it for a soldering, or where I can use it for a melting of both the alloy, eutectic alloy. So if I want to solder differently, that is if I want to solder, take a separate metal of copper, take a separate metal of silver, then I can solder these two metals by using this temperature eutectic alloy, and I can solder these two metals. Okay, if you understand this usage of eutectic alloy, that means you don't need to get every metal. So if I take iron, if I take silver and a single plate, so I need to get 961 degrees. For another silver, if I take two silver atoms or two silver things, then I need a temperature of 961 to solder. If I take the two copper, I need a temperature of 780 to get into melt and solder this. But if I take the two different things like silver and copper, I need only the eutectic alloy to solder at a temperature of around 500 degrees. Though this metal is having of 780, though this metal has melting temperature of 961, but I can do melting or I can do soldering of these two metals using my eutectic alloy of having 500 degrees centigrade or melting point. Okay, this is the main use of eutectic solution or eutectic alloy during the soldering or welding procedures. Yes, hope you all understand the concept of eutectic solution. If you like the concept, please like, share, comment and subscribe, and please kindly let me know which part you like, and thank you.